Yeah, hello everyone. My name is Paul James, and I'm here to present my project entitled Uganda Computer Graphics-Based Diagnostic and Skincare Simulation Platform. Before I dive further into my project, allow me pass you through my abstract because that will give you a bit of overview that actually will guide us along here. Yes, so we understand that Uganda faces a severe dermatology crisis with only 25 specialists. It is mostly said that it is from 20 to 25, which means they don't know the exact number, serving over 45 million people. This crisis leads to widespread misinformation from social media content creators or influencers, which leads to harmful skin practices. And that is the reason why I came up with this project to address this gap through an AI platform that combines accurate diagnostic with educational simulations using tools like vision transformers, GANs, 3D graphics, and alongside this, we shall also deliver a mobile accessible solution that achieves at least 80% uh, diagnostic accuracy while supporting the UN Sustainable Development Goals 3, which deals with the good health, and 5, which deals with gender equality. And that is the overview of all my project. And now, let me take you through my problem statement. My problem statement is divided into two. That is the application domain problem, which actually says, like when we look at it, healthcare inequality persists in dermatological care due to extreme specialist shortage and bias AI systems train. We are here talking about bias trained systems, which means there are already systems trained dealing in dermatology, but they are biased. They have not been trained on African skin. They have not been trained on Ugandan skin. And this is why I insisted uh, on this system. And because the previous methods have actually violated uh, SDG 10 and SDG 3 by excluding African populations from quality digital healthcare. Therefore, came up with this project. And then when we go to our computational problems, developing real-time skin condition simulations for diverse pigmentation requires integrating diagnostic AI with 3D graphics pipelines while maintaining mobile compatibility for low resource settings. When we talk of the current solutions, they fail to address these technical challenges. And as I explained it in the one above. Now, after my we now see our objectives. In our objectives, this is it. We are going to develop a tool, a visual transformer model, so that we can achieve at least 80% accuracy for Ugandan skin conditions. Ugandan skin conditions. When we talk of Uganda, we talk of Africa, but we are dealing with Uganda. And then another one, we are going to create a photorealistic simulation pipeline using guns and blenders, and then build also interactive web platform with 3D avatar guidance in multi languages. The languages that we are going to use here mostly is one, we are going to use English. The second one is Luganda. For the people who don't understand Luganda, they will use English, and Luganda will be mostly used because it is one of the most spoken languages in Uganda. And when we talk of, actually, that is it for our objectives. And then let me take you through my literature review. Our lit, my literature review is based on our site builds upon, but addressing critical gaps in existing work, which is already there. They are already there. And these existing works include generative models. They are already there, like StyleGAN 3, Pixel 2, Pixel HD. They are already there. And they enable realistic synthesis, but they lack African skin representation. That is what we are trying to implement here. And then another one is segmentation architecture. That is the UNet and then DeepLab 3 Plus. It provides precise detection, but it suffers from training bias from the data sets of of the white skins, leaving out the Africans. And then another one is the explainable AI, which is GAN CAM 3, and it increases transparency but remains unused in most dermatology applications. We have, like most of these dermatology applications that are existing, they have not used explainable AI that much. And then finally, localized data sets. We are going to use data set specifically from Uganda. And as I said, when we talk of Uganda, we talk of Africa. So we are going to use one for Uganda to first cater for Uganda. We begin at home. And then another one is, actually, that is it. Then let me talk of my research approach. My pipeline is actually divided into 5 major areas. That is data acquisition, AI processing, simulation generation, 3D integration, and deployment. Now, our data acquisition, we are going to acquire our data set in Uganda. And AI processing, we are going to use visual transformers to classify with UNet segmentation. And then simulation generation, we are going to use Pixel 2, Pixel HD, texture synthesis for condition visualization. And then the 3D integration, we are going to use Blender avatars with 3.js, JavaScript library, real-time rendering. And then we are going to deploy our front end with React.js and backend with Flask for mobile accessibility. That is it for now. And then when we talk of our data set preparation, we are going to use Ugandan skin with over 5,000 annotated data sets, okay? And then these ones are going to be based on demographic metadata, like for example, based on age and gender, because sometimes gender and age, men's skin is different from women's skin. And at some point, when you say man's skin, you might think that it's suffering from some disease, but no. Yeah, so we shall put that classifications there. And then data processing, we are going to get the standard measurement or standardized resolutions, and then the contrast for contrast normalization for consistency in this case. And then let me talk further over model architecture and visualization. When we talk of model architecture and visualization, we are going to talk of the input layer of that AI layer, and then AI core, graphics engine, and then output layer. So input layer is just the user upload image layer, where the user is going to upload the image for visualization, and then the AI layer is going to have the VIT classifier and UNet segmenter and GrandCam explainer. And then the graphics engine is going to use Blender avatar or Pixel to Pixel HD texture mapping. And then we are going to use on our output layer, which is down here, we are going to display the diagnostic report plus the 3D simulation, then plus multiple language guidance that is in Luganda and English. And last but not least, we talk of evaluation plan, quantitative metrics. Well, our diagnostic accuracy will be at least 80 to 85%. That is our target. And then the simulation quality is going to be 0.85 for realism assessment. And then our performance is going to be 5 seconds latency on mobile devices with 2 GB RAM. That means if the mobile device has 468 GB RAM, then we expect the latency to reduce the speed at which it will perform in these devices. Yes, and then allow me to conclude by saying, I'm concluding with the impact of the societal contribution. Now, it democratizes the dermatological access through mobile technology. That's one thing that we should get to know. And then it reduces harmful skin care practices from social media influencers. Those people want to market their products which are not even authentic, not medically approved. And then it's also going to serve as educational tool for medical training and public awareness. And then now our future development. We are planning to partner with Mulago Hospital and other hospitals like Mango for this validation, okay? And then another thing, we are also going to launch our mobile app we are going to launch and deploy it on Play Store for public access and easy access. And alongside that, we are also going to publish it in Nature Dicto medicine platform. And last, we are going to expand this platform to East African countries like Kenya, Tanzania, Rwanda, including South Sudan, East African community, and Africa as large, hopefully, because what Uganda is what Africa is. When we train on Ugandan skin, we have already trained on African skin. Thank you so much. This is I remain Paul James.